Okay, so today on your notes journal, we're going to start learning about the integer rules, which are your negatives or subtraction. Whenever you're dealing with negatives or subtraction, I want you to think of integer rules. So here comes rule number one. Rule number one is the one that if the signs are the same, and I'm capitalizing this on purpose, you're gonna see right now why. If the signs are the same, comma, I will add and keep the sign the same. Questions with that one? Rule one, if the signs are the same, I will add and keep the sign the same. Now you're probably like, what does all this mean? Right now I'm gonna teach you. So the strategy for rule one is we use this big word, like we make it big like this, same. And the reason I put the word same is because the A is gonna remind me to add, and the E is gonna remind me to keep. So this is actually the strategy. This is a whole note. If the signs are the same, I will add and keep the sign the same. So I need to remember that if the signs are the same, I'm gonna write quickly that my strategy same, and I'm gonna put A add and E keep. And right now that I go over it, you're gonna see like what I'm talking about. So right now you might be like, oh, ¿de qué está hablando? Ahorita vas a ver de qué estoy hablando. So let me do an example so you can see de qué estoy hablando. Negative 4 plus negative 2 equals. Okay. So your first job, this is a problem. This is my question. Negative 4 plus negative 2. That's my problem. That's a question. So I already have it there already. The second thing is to get the facts. Now the facts is that whenever we're dealing with negatives, we're gonna label it. So is that for a negative or a positive? So put an N for negative. Is that 2 a positive or negative? También negative. Good. So now I notice that both of them are negative, so the signs are going to be the same. And according to rule one, they told us that if they're the same, we're going to what? Add. So let's add them. What's 4 plus 2? 6. And we're going to not just add them, we're going to keep the sign the same. So if it's negative, negative, and we want to keep it the same, he'll be what? Negative 6 would be the answer. That's how easy this is in this case. Questions? Now, to prove that my rule does work, to prove that it works, we're going to draw a number line. So I'm going to draw a number line to demonstrate with a model that the rule works. So draw a number line. Now I notice that all of them deal with negatives, so I'm going to put my 0 to the very end. We're not putting nothing in this order. We're going to show you how to use a number line to solve negative 4 plus negative 2. So now I'm going to go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. I just did 8. Now some kids who have asked me, and how do you know when to stop? Well, look at the numbers. Negative 6 was the most that we went on the negative side, so that's why I added like 2 more or 1 more extra just in case. Questions? No. Now how do I use the number line when I'm adding integers, when I'm adding the negatives? Well, everything begins at what number? 0. So let's mark a little mark here on top of 0. So we're going to begin here. And since I lost 4, you see the minus 4, the negative 4? I lost 4, let me lose 4. When you lose, you go to the left because the L left, you're losing. So I'm going to go 1, 2, 3, 4. Right there, draw an arrow. That's showing that you have lost 4. I just lost $4, let's pretend. Let's make another mark because we also added more losses. So I added more losses. So it's still losses. So guess what? Do I go to the right now or do I continue going to the left? To the left because there's still losses. So I'm going to, yes, I'm going to add, but more losses. So I'm going to continue trying to the left. How many losses more? Two. So guess what? One, two. So where did you stop at the end? And that's why the answer is -6. Do you see what I did? Yes or no? So basically I lost 4 and then I lost 2 more. That stops me at -6. Okay? I'm just going to show you with the thing. Okay. I have it here. Here's what's going on with the number. As I watch the videos, I try to make them better. That's why. So the first 2 videos I didn't like them, so I said, yeah, let me just do it again. So we're always starting at 0, and here's what's going on. We lose 4. 1. Watch the little hand right there. 1, 2, 3, 4. So right now I'm at -4. But then I lost 2 more, so I added more losses. So I added more losses, so I'm gonna continue going here. 1, right there on 5, right? 1, and then 2 more. Where did I stop? -6. That's why the answer is -6. That's why this rule works. Okay, if the signs are the same, I'm gonna add and what? Keep the sign. Questions? Okay. Now the other way I can prove this right also, to prove that this method works is with integer chips. So miran ahí abajo, these are called integer chips, these. Okay? Now the yellow ones represent the positives, and the red ones represent the what? Negatives. Usually on a paper, like a black and white paper, the black ones, the ones that are shaded, will represent the negatives, and the white ones, the ones that are not shaded, represent the positives. But they will usually give you a key, like a map key, and tell you, hey, these are the negatives, these are the positives. But let me show you how this works. So I lost 4, right? So what I need yellow or red? Huh? Red. 1, 2, 3, 4. Why red? Because the red ones I just said are the what? Negatives. So I lost 4. But then I want to add 2 more losses. So what do I need again? Another red or yellow? Red again, because they're losses. They're negative. Look. How many? 2. Anything else that happened? No. These are the facts. 4 negatives and 2 positive. 2 negatives, I'm sorry. So now the total together is 2, 4, 6. That's where we get the 6. And they're all red. That's why they're negative what? 6. Questions? Now, you're not going to have this in the test, are you? No. So we're going to have to create what I call the number line is one option, but this is the integer chip. So we can do negative on the left side, positive on the right side. And why do I like to do that? Because from 0, the positives on the right side, the negatives on the left side. So all we're going to do is we're going to draw. So how many do we have negatives? Right here. 4. So I'm going to go 1, 2, 3, 4. Question with that part? And then we also have 2 more negatives. So guess what? 1, 2. Do we have any positives? No. So it will stay empty. Now just count. 1, 2, 3, 4, 5, 6. 6. And they're all what? Negative. That's why they have -6. Now some kids will say, pues I like this one better. The problem with the table and even the number is that what if it's -144? I don't think you're going to draw 144 negatives. That's why I really believe that the fastest way is to learn the rule. If the signs are the same, I'm going to add and keep the sign the same. Questions? Now, you're a calculator kid, because I haven't mentioned that the calculator kid, la vas a tener hecha, but right now I want you to try to learn the rules. You're a calculator kids. Let me show you how to punch in the negative stuff. Please listen, because this is new for calculator students too. You see that number 4? He's what? negative. Now, most calculators allow you to press the negative first and then the 4, not this one. So we have to press actually 4 first and say, you know what, 4, you're not a positive, you're a negative. So you're going to press this button here, and now he became a negative. Did you see that? So let me start again. You see that 4? It's going to be 4. But he's not positive, he's actually what? So I'm going to press a negative. Now you see the next one, it's a plus sign. So press the plus sign. The next one is negative 2. So what are you going to press first? 2. And then tell us that he's what? Negative. Now we press enter, and guess what? We get exactly the same answer. Questions? So the calculator kid, really, you don't need to learn the rule because the calculator knows the rule. However, I prefer that you learn the rules too. They're not hard, and then the calculator can be your way to check if you're right. Questions? So that's why I'm making everybody copy this. But calculator kids, that's the way you use the calculator. Right, I'm going to show you more things on the calculator with negatives and positives. Sorry. Okay. Let's bubble with number 1 because we're done with number 1. And we'll try another one. This is the one that is tricky, so you better listen. Number 2. This one can be tricky for some kids. Negative 3 minus 4 equals. Okay? So there's the question, there's the problem. Now let's get the facts. What's the 3 in this problem? Negative. And what's the 4? Also negative. So can I use the rule same? Of course we can. So let's write it down. And what does the A tell you to do? Add. And what does the E tell me to do? Keep the sign the same, right? To keep the sign the same. So now listen to the rule. Don't do whatever you want. Listen to the rule. But before you listen to the rule, let me tell you what kids do to me. Before we continue. Don't copy red in my class. We don't copy red. Here's what kids do to me. They draw the rule. The strategy is right there. They draw it right. Let me do it red. And they still do this to me. They'll go 3 minus 4, negative 1, sir. Okay. First of all, I just told you to what? Add. And this kid decided to what? Subtract. And you know why you guys subtract? I hope you're listening. Because you see the minus and you think, it's subtract. But you're losing 3 and then you're losing again 4. Now to prove this, that it doesn't make sense, let's pretend that you were in the dance, right, Miss Orende? I saw you there. So Miss Orende in the dance, I saw her there in the dance, and I was there standing there, and Miss Orende came to me on Friday and said, "Sir, I'm kind of hungry. Can I borrow $3?" Let's pretend. She's like, I can do that. Let's pretend. So now she owes me $3. Do you agree? Yes. As the dance went along, she comes again. And she says, "Sir, I'm still hungry. Could I borrow? Can you spare another $4? That one or date, here's $4. So now she owes me another what? $4. So her problem is like this one. She owes and she owes. Today is Monday. Tell me if this makes sense. I loaned her $3. I loaned her $4, and today she's supposed to pay me back, and she tells me this. Sir, here's your dollar because I only owe you $1. Does it make sense? No. I'm gonna think here's la rata de dos patas. Like la canción. ¿No es la canción? Sí, why not put it so you can hear it? The reason that she thinks that she owes me only $1 is because she subtracted. But it doesn't make sense with the story. You lost 3, you lost 4, so you owe me 7. Right? Here's another thing. Football. My running back, he gets tackled 3 yards behind the line of scrimmage, so he's at negative what? 3. Second down, he loses 4 yards again, so he's now at negative 4. He's not going to tell me, "Hey, coach, put me back in the game. I've only lost 1 yard." No, sir. You have lost 3 and you have lost 4, so you have lost 7. That's why we do add and keep when the signs are the same. You understand? Because I get a lot of kids. Look, right now you're saying yes, but when I give you the first actual homework, I'm gonna see some of you put -1 because you don't want to follow the rule. Follow my rule. Because right now I'm showing you why the rule works. I'm giving you a real world example of Lauren Day that she borrowed $3. Let me give you one more. Let's change it to Hugo. So Hugo le presta el money, la mamá dice, tenga mijito $3 para que le compres hamburguesadas ahí cuando está vendiendo papitas. So he gets $3, que va con la lady que vende papitas, chakis y compra. Según va a comprar, pero he lost them. When he went to the restroom, maybe he flushed them down the toilet. I don't know what happened, but he lost them. So he goes home and says, "Oh, mom, guess what? I lost the $3." So he's at -3. He's short $3, right? -3. On Tuesday, the mom in the morning says, "Mijito, I'm gonna give you money again. You take care of it, mijito. Yeah, you're in middle school." So they got $4 more. Well, guess what? In the bus, he dropped them. So now he lost how much? $4. Now he comes home and says, "Mom, are you leaving money tomorrow? Because guess what? I dropped the money again. I think in the bus. But don't worry, Mom. I've only lost $1 the whole week." Does that make sense? No, he has already lost how much? 7. That's why we add and keep. It's a negative situation. We're just going one way. We're adding more negative stuff to yours. Okay? Questions? Now let me do it the right way. So I just wanted to share with you what kids do to me every year. They want to do subtract because your brain tells you, subtract, come on, subtract. That's what you're doing. No, you have to go with the rules that we're dealing with negatives now. Okay? Don't go with the, because in elementary you would subtract, right? That subtraction symbol means to subtract. You were actually working with negatives since elementary. Okay? But usually the first number was a big positive that you had enough to subtract. But here, you lost and you lost. So it's still more losses. Okay? Sir, I did go with you. Yes, but not for money, right? No. Everybody goes to me. Okay. Here we go. Negative, negative. The signs are the same. So I should be what? Add and keep, not subtract. So let's do it. What's 3 plus 4? 7. And we're going to keep it negative. That's the way you do it. To prove that this makes sense, let's draw a number line again. As you can see, that it's going to make sense. I need at least 7 because that's, look, 3, 4, 7. I need at least 7. So -1, -2, -3, -4, -5, -6, -7. At least -7. I like to always put an extra one. Okay? Now let's go down the facts. The first thing that happened, starting from 0, we lost 3. 1, 2, 3, right there. The second thing that happened, we lost -4 more. So we're still going to the losing side, to the left side. So I'm going to lose how many? 4 more. 1, 2, 3, 4. We lose 4 more. So we lost 3. We lost 4 more. Where did you land? Not 7. -7. That's why the answer is -7. Integer chips. How many red do I need first? How many red? 3. 1, 2, 3. And then we have 4 more that are also red. 1, 2, 3, 4. They're all red. That's why it's what? -2, 4, 6, 7, -7. Questions? Now let's do a table so we can prove that the shifts always work. Negative on the left side, positive on the right side, because that's the way in 0 it is. So we have 3, 1, 2, 3, and then we have 4, 1, 2, 3, 4. That's a total of 7. That's why the answer is -7. Now some kids, like I said, some of you say, I like to do the table mejor. I would just stick to this. But this works too. And the reason I want you to learn the rules because of when these numbers become bigger, like -83 plus -50, I don't think you're gonna want to draw 83 of these negatives here, or the thing going all the way to the number line forever. Do you understand? So that's why I prefer that you just listen to the rule. Add and keep. Add 7, keep it negative. There, I'm done. Example number 3, we're not going to draw numbers, we're just going to go with a rule. Ready? Example number 3 says negative 5 minus 4. Negative 5 minus 4. Let's get the facts first. Who's the 5? Negative. Who's the 4? But there's a minus, and the minus makes him a negative. When you subtract things, that's something positive? No, you're losing. That's negative. You understand? So are the signs the same? Yes or no? Yes. So let's put the word same. And what does the A tell you to do? Add. The E, keep the sign the same. So what would be the answer here, guys? Negative 9. That would be the answer. You don't have to draw a number line. That's it. The number line, if I wanted to draw one, it would be like this. It would go 1, 2, 3, 4, 5, and then 4 more. 1, 2, 3, 4. You're going to land in negative 9. You see? Calculator kids, how do you do these now? Same way. But I'm going to remember that this guy is not a negative symbol. He's a minus. He makes him a negative. But look, check it out. 5, put 5. Is he positive or negative? Negative. Minus 4. Now, don't put a negative again, because you already said minus 4. You leave it like that. Don't say, oh, he's negative. He was, by you putting minus, he makes him already negative. What do we get? Now, what the calculator sometimes mess up in this one, they go 5 negative minus 4, and they put up negative. Now you have created a double negative, which is another rule, and it's going to give you another answer. So again, calculator kids, when we're dealing with, when there's a minus, we're going to do this. 5 negative, because that's a negative, minus 4. That's it. Don't make him negative, because you already said minus 4. That makes him already a negative situation. And now you have the negative 9. You understand? This symbol is not a negative symbol. It's a minus symbol, which makes him a negative. You don't have to make them a negative on the calculator again. By putting minus, that's a negative situation. Questions? Good. Turn the page. We're going to begin rule 2. Behind it. Rule 2. There's 4 rules that I'm going to teach you about integer rules. Rule 2. If the signs are, guess what? Let's see who can finish. If the signs are what? What do you think I'm going to say now? The other one where the signs are the same. If the signs. No, we already did same.
Different.
Good. If the signs are different. If the signs are different now. Because the other one, the signs were the same. I know what you're talking about. Since you mentioned it, then let me talk about it. Before I continue. You're probably wondering, like, why didn't you do anything with positives? Because those are like from kinder. But let me do one. 3 plus 2. What's the 3? Positive. What's the 2? Positive. Positive. So the signs are the what? Same. So what can I do? Add and keep. So what's 3 plus 2? So it's going to stay positive, so that's it. So that rule works obviously with these two. Why didn't I give you an example of positives? Because positives, I said, if it's positive, just work the way you've always worked. You don't have to deal with rules. Just go to it, add it, that's it, you're done. Okay? It's when there's negatives that I have to worry about it. So tomorrow I'll continue with rule number 2 with you all. I'm actually going to continue recording the whole all rules right now by myself. And tomorrow I'll just make you copy it. But let me pause it for now. So rule number 2 is if the signs are different, just like rule number 1 was if the signs were the same, I was going to add, well, if the signs are different, we'll be subtracting. I will subtract. And this time I'm going to keep the sign of the greatest absolute value. So rule 2 is if the signs are different, I will subtract and keep the sign of the greatest absolute value. We'll talk about absolute value. So absolute value is the distance from 0. Okay. Another thing we need to know is that this symbol is the symbol for absolute value. So when you have two bars like that, that means absolute value. So here's an example of absolute value so you can get an idea. The absolute value of -7 will be 7. Why? Because if we go to a number line, look for a number line quickly. So for example, if I say, well, let me put 7 since you can see 7. And then 7 and 1. Let's see. Okay, so here's how it works. If I say the absolute value of -7, well, -7 is right here. Okay? And absolute value is how far you're from 0. So it's going to be 1, 2, 3, 4, 5, 6, 7. So the absolute value of -7 will be 7. Okay? Now if I say the absolute value of -3, the answer would be 3 because you're 1, 2, 3. The distance from 0 to -3 is 3. So basically the 0 all the way to -3 would be 1, 2, 3 distance. That's why the absolute value would be 3. Now I could also have the absolute value of a positive number, absolute value of a positive 4. Remember that these two bars mean absolute value, so absolute value of 4 will still be 4. 1, 2, 3, 4. So the answer will be 4. So absolute value is just how far you're from 0. Okay. How far you're from 0, that is your absolute value. Let me do one more in a positive way. Let's say you have the absolute value of positive 4. That would be 4. Okay? These are little notes so you can understand what I mean. Now the strategy, I call the strategy diff. And the reason I call it diff is because they're different. Now in elementary, when you have to find the difference, you would subtract. So diff will remind me of difference, which is subtract. And we're going to keep the greatest, that's a greater than, right? Greatest absolute value. So this will be my strategy. Subtract and keep the greatest absolute value. It sounds all complicated, but once we do one, you're going to see that they're not that bad. So this would be example 4 for this rule. So number 4, let's say that we have let me see, we have -7 plus 8. Okay, so we start like the other ones. We will start with, okay, this guy is negative, this guy is positive, right? Now, this time the signs are not the same, so I will not be using rule number one same. I will be using rule number two. They're different. So the rule would be diff, and I'm going to subtract. And I'm going to keep the greatest absolute value. Okay, so this is a strategy to remember that if they're different, diff, I'm going to subtract. So let me subtract. 8 minus 7 would be 1. Now here first, the absolute value comes. How far is negative 7 from 0? 7. How far is 8 from 0? 8. So 8 has the highest absolute value, so the answer will become positive. It will stay positive. Okay? So again, they were different, negative, positive. That's why we subtracted. That was how we got 1. Who did we keep? The one that has the greatest absolute value. The absolute value of 8 is 8. The absolute value of negative 7 is 7. So he will have the greatest absolute value, and that's why we keep it 1. To show you the number line, why this rule always works. Okay, this time I'm going to put 0 in the middle. Because we actually have some positives, so I'm going to put a couple of them. 1, 2, 3, 4, 5, 6, 7, 8. I put 8 because that was the highest that we ever went in case we go over there. And then negative 7, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay? Now to prove the number line, we begin at 0. And here's what happens. We lost 7. So we're going to lose 7. 1, 2, 3, 4, 5, 6, 7. So right now we're at this point. That's losing 7. But this time we just didn't lose. Like the other time we're just going one way. This time we're actually losing, but then we're gaining 8. So we'll put a mark. And basically this is how it works. If I lost 7 and I start gaining 7, I'm going to be back at 0. So by me losing 7 and then I gain 7, that will take me back at 0. Those are called 0 pairs. Okay? But not only did I gain 7 to go back to 0, I actually gained 8. So an extra 1, which is right here. So I gain an extra 1, so that's how I land in positive 1. Now let me explain what this means, like 0 pairs. Basically, every time that let me put a number line here. The one from that we have here, so you can get an idea. Let me go to the board. 0 pairs work this way. If somebody would gain 1, that's plus 1, but then they lose 1, minus 1, they're back at 0, that's called a 0 pair. Basically, it's like nothing happened. I gain 1, lost 1, I'm back at 0. Okay? If I lose 3, 1, 2, 3, but then I gain 3, 1, 2, 3, I will be back at 0. So here we would have 3 0 pairs. Okay? Basically, they cancel each other because you're back at 0. Okay? So that's why the absolute value is important. So right now, the one that we just did, we had lost 7, but then we gained 8. So we gained all 7 back, which got the 0 pairs, and then we gained an extra 1, which ended up at 1. Okay? So by me traveling 7, 1, 2, 3, 4, 5, 6, 7, losing, but then I gained them again. So I'm going to make it green. So I gained 1, 2, 3, 4, 5, 6, 7, back at 0, 0 pairs, but then I needed 8, so 1 more. That's why the answer is positive 1. Okay? So that's why we subtract, is we're basically losing and then gaining, or opposite, gaining and then losing, so that those are becoming 0 pairs, which means you're losing and you're subtracting that gain or loss. So in an integer chip, with integer chips, basically we would get 7, negatives, 2, 3, 4, 5, 6, 7. So that's the negative 7 right there. This card, negative 7. And then we have 8 that are positive. That will be the yellow. 1, 2, 3, 4, 5, 6, 7, 8. So we have 7 that are negative and 8 that are positive. Well, that will become a zero pair, so it's gone. This becomes another zero pair, it's gone. This becomes a zero pair, it's gone. This becomes a zero pair, it's gone. That's why we subtract. When they're different, we subtract, we're creating zero pairs. This becomes a zero pair, gone. This becomes a zero pair, gone. And this becomes a zero pair, gone. So what's left only? 1, the yellow. Like I mentioned in class, the yellow represents positive, so that will be positive 1 the answer. Okay? You can represent, and you're gonna have these chips with you, like in a test or a star test. You can actually represent it with a table. On the left side, I like to put the negative chip because on the left side of 0, that's the negative. And on the right side, I like to put the positive chips because on the right side of 0 is the positive. So we have 7 negatives. I'm going to go 1, 2, 3, 4, 5, 6, 7. And then we have 8 that are positive. 1, 2, 3, 4, 5, 6, 7, 8. So this is a 0 pair, 0 pair, 0 pair, 0 pair, 0 pair, 0 pair, and 0 pair. So 0 pairs means that they became 0, which is nothing. And then we only have 1 that's positive, and that's why it's 1. And that's why it's important to understand that whomever has the highest absolute value will have the most chips. And that's how we decide what side do we keep. So in this case, 8 had the highest absolute value, and that's why the answer stayed positive. Okay? Let's do another one so you can see. Number 5. So let's pretend we have now this question. I don't know, negative 4 plus 7. Okay? So first of all, we're going to get the facts. So the facts is that we have a negative number here and a positive number. That means that we cannot use the rule. We cannot use the rule saying because one of them is negative, the other one is positive. So we're going to be using the rule diff. And in math, diff is difference, and in difference, we will subtract. And we'll keep the greatest absolute value. Okay? So we have a 4 and a 7. We subtract those two, and that will give me 3. Okay? And who's the highest absolute value? Well, the absolute value of negative 4 will be 4. The absolute value of 7 will be 7. So positive wins again. So we will have positive 3 in this case. The number line will look like this. Let me put a number line. The number line will look like this. Always beginning at 0. We use 4. Right there. That's using 4. But then I gained 7. So I'll mark another mark here and we gain 7. So that's going to be 1, 2, 3, 4. And you notice once I hit 4, those are the 0 pairs. That's why we subtract those are gone. Then we have 5, 6, 7. Right? And that's why the answer will be positive 2. So basically, these are the 0 pairs. As I'm gaining 1, that will be 0 pair. Gaining 2, that will be 2 0 pairs. Gaining 3, 3 0 pairs. Gaining 4, 4 0 pairs. That's why we're subtracting those 4 because those are 0 pairs. And then whatever is left would be this 1, 2, 3. The answer is positive 3. If you want to do an interchange table, we can also do it that way. We do the table. have our negatives on the left side, positives on the right side of the number line. And we have 1, 2, 3, 4 that are negative. And then we have 1, 2, 3, 4, 5, 6, 7 that are positive. 0 pair, 0 pair, 0 pair, 0 pair. And the answer would be 3, and they're positive. Okay? Let me do one more of this. Number 6. Let's say that you have, I don't know, -5 plus 3. Okay, so we have a negative and a positive. So the rule will be diff again. So it's going to be diff. When we do diff, we're going to subtract, and we need to keep the greatest absolute value. So 5 minus 3 would be 2. And the absolute value of -5 is 5. The absolute value of 3 is 3. So this time, -5 has the greatest absolute value. So that's why the answer is going to stay negative. Basically, this guy is farther from 0. So you won't make it to the other side because you are farther from 0 than the 3. So whomever is farthest from 0, that's the sign that we keep when we do diff, the rule number 2 diff. Okay? Now let's see if it's true. We're going to use the energy chip tape so you can see that it's true. Let's see if it's true that we're supposed to have kept it -2. So we have negatives on the left side, positives on the right side. 1, 2, 3, 4, 5. And then we have 1, 2, 3. Okay? So like I mentioned before, this is a 0 pair, 0 pair, 0 pair. So you notice the only thing that's left on the table is 2, which are the 2, and both of them are negatives. That's why the answer is negative. Okay? If we use the number line, which says -5, so we first lost 5. So starting from 0, I lose 5. 1, 2, 3, 4, 5. I lose 5. But then I gain 3. So now I'm going to gain 3. 1, 2, 3. So this time I did not make it to the positive side because of the absolute value. So if you notice, this becomes 0 pair, 0 pair, 0 pair. So you're losing 3. You're just left with 2 more. And that's why the answer is right here. The answer is -2. Okay? That's with the number line. So we'll stop there in rule 2. This is just to help you out and hopefully understand it a little bit better than before. Vamos a pararle aquí.